End of Module 4 Review, Grade 4, Engage, New York. Problem number 1 and hopefully 2. All right. Number 1, find and draw all the lines of symmetry in the following figures. If there are none, write none. So remember that symmetry means that if you folded the figure on that line, that it would match up exactly along the fold. So let's start with A. When we look at A, if I went from this corner across and folded it, this side would only come down to about there. So it would not be a line of symmetry. And so then you have to think about that for each of the other corners. If I do it there, this corner would come to here. So that also would not make it symmetrical. And then the last one I check is from here. And this has a right angle. This one has a right angle and this one does not. So there's no way those can match up. So the answer for this one is none, because there are no lines of symmetry. Then when you do it for B, same idea. If I come straight here, this side folded over would match up to that side. So there is one line of symmetry for sure. When I go from this side to this side though, this line is shorter than this one. So it would only come to about there, which means it's not going to work either. And then on this side, also not going to work, because this one is only going to come to about here on that side because it's shorter. So that would give us only one line of symmetry here, and so we draw that. On C, if I try to go from corner to corner, those will not fold on top of each other. When it comes across, this corner is going to be about there somewhere. Same thing if I go this way. So then you can think about it in half like this. But when that folds in half, it's just going to have these two corners come down to here and here. So that's not going to be lines of symmetry either. If I fold it in half, and I encourage you the day of the test, think about where your line is and then fold your piece of paper, hold it up to the light. See if you can tell if the lines would all match up. And here they would, because this side is the same length as this side. This side is the same length as this side. So it would fold over and cover up exactly the same area. So that one also has one line of symmetry. And then on D, there are none. Because if I fold it here, this corner is going to be down here. Well, you need something to match up with that corner there. And if I fold it here, ooh, that looks good for here and here. But when you fold it over, this one is going to stick out this way over here. So that one won't work either. So this one is also a none. E says for each triangle listed below, state whether it is, and then we have to write acute, obtuse, right, and we have to write whether it is isosceles, equilateral, or scalene. So triangle A, this one, is a right triangle because it has a right angle in it. So I'm going to write right. Then to choose between isosceles, equilateral, or scalene. So equilateral triangles have 3 equal sides. Isosceles triangles have 2 equal sides. And scalene triangles have only 1 equal side. Give or take. So a couple of specific rules, but that'll get you the idea. So in this one, this line is shorter than this line. And this line is a tiny bit shorter than that line. So it is a scalene because none of them are equal. I can't remember what I said for scalene, but like 1 equal side, that means they're all 3 different because it's only got, each side is its own length. All right, now let's look at B, triangle B. Here we go. So as far as being acute, obtuse, or right, I could use my right angle checker, and none of these angles are going to fit with the box or the corner of a piece of paper. So it is not a right angle. Let's see if they're obtuse. None of them are larger than the right angle, so it's going to be acute because all three angles in the triangle are smaller than a right angle. Then let's look at deciding if it is an isosceles or an equilateral or a scalene. So when we think about that part, does it have 3 equal sides? Well, it does not, because the base is shorter. Remember, we said the base would only come up to about there? So it is not an equilateral. I can cross that out. Isosceles, does it have 2 equal sides? Well, I think it does. I think that this side here is probably equal to that side there. So those 2 sides are equal, which would make it an isosceles triangle. Sorry, there's an extra S in there that I forgot. There's problem 1. Let's go ahead and see if we can do problem 2 as well. Problem 2 says, in the following figure, ABCD is a rectangle. The reason they tell you that is so that you know that you have right angles in each of the corners, because that tells us something. What does it tell us that those angles are exactly 90 degrees? That's exactly what it tells us, that they're exactly 90 degrees. So without using a protractor, determine the measure of angle DAC. Remember that the A is in the middle, so that means it's got to be here. So we have angle DAC. That's what we're looking at. Then we need to write an equation that could be used to solve the problem. All right, well, if I know that this part of the angle, BAD, is 90 degrees, and then I can see that BAC is 40 degrees, let's subtract that, because when I subtract that, I get 50 degrees. Well, that's what this one must be. So this triangle this angle right here, the DAC angle, must equal 50 degrees because there's no other way for it to add up to 90 in the corner with 40 as its other angle. It says to write an equation. Some of your teachers might say that that's an equation, but if you wanted to be careful or certain, an equation might look like this: 90 degrees minus 40 degrees equals 50 degrees. For my class, it's a word problem, so we would have to write out that angle DAC is 50 degrees because 90 minus 40 equals 50, or something similar to that. Don't forget your period. All right, there's problems 1 and 2. See you on the next one. Best of luck on your test.